after verifying that I'm actually human. Yeah, sorry, today I didn't sleep well. I expect this to be kind of one of the worst attempts at LeetCode, but okay, the rating for this problem is not too huge. Should be doable for me. Signature, okay. Design an algorithm that accepts a stream of characters and checks if a suffix of these characters is a string of a given array of strings words. Okay. So we have stream checker that gets words and Boolean query accept a new query. It adds a letter and returns if any non-empty suffix. Is there? Okay, interesting. So tests. Let's say we are creating a stream checker with words CD, DE, and we start querying. Query A, we always add one letter. So I will be doing, okay, so query A, false. Query B, true. Query A, false. Query C, false. Oh, actually, let's add A, B, A, C. And then this will be interesting with true. And let's add D, true, and let's add E, also true. So the problem is, right, how do we do that fast? The thing that I'm thinking about is try, and basically we build a try of words on each letter. We query from the end of the string. So this is not the best possible approach, but it will be of m, where m will be equal to length of the max. Okay, max of lengths of words. Yeah, it's word for word in words. Just to be clear what I'm talking about, right? Because that will be the deepest possible thing that we can go to given our suffix. Okay, so that's on each query. On each query. Then the problem is that probably there is some additional improvement that we can make so that it runs even faster than that. Because it feels like when we are adding a new character, we can we're basically adding to the root of the try. So we can also create some optimizations that will trade space for runtime. So no, I actually don't think so. So I was thinking like creating all the possible second level tries and try to match those with the specific prefix. Yeah, probably doesn't work. Yeah, let's just implement the try then. And implementation. Okay, so size characters will be let's add class try. Self next will be equal default dict of try recursively, self end equals false by default. Okay, then for word in words, for letter in word, node, okay, node equals self root, next node equals node next letter. And once we have exhausted everything, so we do node and equals true. So I think this populates our try. Now let's do query. Oh yeah, let's also store self letters, which is just a list. Self letters append letter, and then I will be equal length of self letters -1, while I is bigger than -1. Next letter is I. Node equals self root if next letter not in node. Okay, first if next letter not in node next, return false. Else. So we have started iterating. Node equals node next letter. I minus equals 1. Maybe let's do this in the end. And here we need to also return if node and return true, return false. Yeah, okay. This looks oh, I should be adding reversed words, right? Yes, I should be adding reversed words. Forward word equals reversed word. Yeah. So now let's check if it works. So first of all, let's try and create the try, and I will be creating it outside of the implementation for our, this is our string checker. So we start B A. Okay, so let's do root, then it's B, then it's A. Okay, root BA, root DC, root ED, and CA, BA. And I will mark a star, something that ends here. Let me also do something like AC or CB, just so that we have some other BD. So if we have BD, then CD and BD, and it will be DC and DB, and here we'll also have star, just so that we have some variance here. And here we have a star, and let's also add AC, and then here we'll also have a star. So this will be our try. Let's now add letters one by one. So we are adding letters, and first it's ABA, ABA, CDE. This is what we will be running. Okay, so here are the letters. Let me just copy our tree here below. And our letters start with A. So we try to find, we go, okay, self-letters append letter. I will be pointing, let's actually store it here. So I will be pointing to this element, and then we will be checking node equals self-root, next letter, self-letters I, okay, so it's A. If net next letter not in node next, return false. Okay, so this is correct, we should be returning false. Now we are adding a B. So we start with B, next letter is B, so we have B, and we are moving towards the back, so B points to this try, and it's now A, and A points to another try that is marked as the end. So we first do node equals node next, and we move to from this to this, and yeah, basically we start with self letters I, next letter node next B, yes, true. So we come to node next, which is A. We first come to B, and yeah, we start with root, we first come to B, then we come to A. In node next we and then we go to the end. Okay, so this also looks correct. Let's just try and run this. Okay, time limit exceeded. Why? Oh, it didn't exceed. Nice. We have solved it in like 90 minutes. I think it's a new record. New record for me solving hard problems. Thanks everyone. See you next time.